The James Webb Telescope has been furnishing us with tremendous pictures from space for 2 years at this point. While the most impressive space telescope of all time has been looking into the deepest and oldest secrets of the universe, it has not only provided space experts with numerous groundbreaking insights, but also a number of tempting mysteries. How is it that galaxies are sleeping out there, which, according to our understanding, shouldn't exist by any stretch of the imagination? Why does the value of the Hubble constant, measured by Webb, which describes the expansion pace of the universe, essentially not match our current models? Well, these are questions to which scientists are currently desperately searching for answers. Luckily, the James Webb Telescope isn't just capable of revealing the most confounding secrets of space, but also of its overwhelming, almost startling beauty, which constantly reminds us how little we are in the grand plan of things. People like to describe themselves as the crown of creation. Whether we want to accept this not-so-humble title is obviously up to each of us to decide for ourselves. However, when it comes to the subject of the most amazing creators of the universe, Webb clearly merits the honor. But before we get it wrong, the James Webb Telescope has obviously not uncovered some foreboding power that made the universe. Instead, along with Hubble, it has provided a phenomenal combined view of the pillars of creation, which are among the most famous photographic subjects in modern space exploration. Approximately 7,000 light-years from us in the open star cluster of the Eagle Nebula, we are looking at the shining pillars of a stellar nursery, first captured by the Hubble Space Telescope. Essentially, stellar life begins in thick, cool clouds of gas and dust when the gas clusters break down under their own gravity. A protostar is formed first, which attracts matter from its nearby surroundings. When the glowing progeny has developed enough mass, it can ignite hydrogen fusion in its interior and become a true star. However, stars often don't form on their own but in collective unions, like the pillars of creation. While the Hubble's famous snapshot from 1995 still shows the stunning structure in the visible wavelength, the James Webb Telescope explored it in the infrared. The combination of these two pictures ultimately gives us entirely new insights into this structure, whose finger-like extensions are significantly larger than our entire solar system. While countless infant protostars lie dormant in the dusty gas clouds, their intense radiation and stellar winds have blown expanding holes into the dust cloud shells, giving them an unmistakable appearance. Given this amazing sight, it's no wonder that the pillars of creation were among the first subjects of the James Webb Telescope in 2022. Now, NASA has combined the Hubble and Webb images to reveal even more details. While the infrared images uncover the stellar infants and cool gas parts, the visible light shows the scorching hot glowing gases of star formation. Essentially, the display isn't just available as a photograph but also as a video. If you watch the corresponding clip, you will be treated to an intriguing journey through the three-dimensional pillars of creation. Throughout this, the view switches between visible and infrared light, once again demonstrating why it is so important to explore the unique parts of the same structure with more than one space telescope. The stellar family picture, no less enchanting than the combined perspective of the pillars of creation, is the family photograph that Webb recently snapped in the Snake Nebula, 1,300 light-years away. In detail, we are also dealing here with a stellar nursery, more specifically a so-called reflection nebula, which produces no light of its own but is illuminated solely by the light of the stars in its interior and its location. For the telescopes of the past, nebulae were often still an impenetrable optical barrier. But Webb's near-infrared camera is able to penetrate the dust and gas mixtures somewhat, and thus make visible those things that have evaded our observational vision for so long. While the gas and dust in the images are an energetic orange, red, and blue, we can also see the intense shimmer of the countless young stars. Some of these radiantly bright celestial bodies are only 100,000 years old, which means they are still in their infancy in galactic terms. But one day they will have the mass of our Sun. One detail of the star family portrait is especially striking: the flame-like structures at the top left of the picture, which are reminiscent of giant shreds. These are the remnants of gas and radiation outflows from young stars, which appeared in earlier images in visible light either as obscured spots or even completely undetectable. NASA compares these protostellar outflows to rain tumbling from the sky during a strong storm, and this is the first image to show that the outflows all point in the same direction. However, what for us are just designs moving from upper left to lower right in the pictures are significant research clues for the scientists. This picture evidence supports the hypothesis that young stars tend to spin in the same direction when their gaseous birth envelopes break down. But what's the story behind the dark bars at the bottom left and top right of the picture? Has NASA applied the sensor pen here to make a couple of UFOs unrecognizable? Well, sadly, it's not quite that astonishing. The dark square shapes simply indicate missing data. The first photograph of the superJupiter. 6,911 exoplanets in 4,941 systems. The number of known planetary worlds orbiting a host star other than the Sun is growing continuously. Scientists have already added some extraordinary celestial bodies to the star maps as part of the planet hunt. These include, for example, the gas giant HD 189733b, which is only 63 light-years away and, according to the latest discoveries, smells like rotten eggs. However, what at first sounds rather unusual or funny is actually the first evidence of hydrogen sulfide on an exosolar planet. Apart from this, experts have also proven to have the right nose in other regions, since we now know of an entire series of nearby exoplanets, some of which are Earth-sized and even potentially life-friendly. In this regard, K2-18b, in particular, has been making headlines for years because this celestial body is in fact associated with being a full-fledged ocean world, where life might have already emerged. In detail, Webb's near-infrared spectrometer recently captured some potential biosignatures here, specifically the spectral marks of methane, carbon dioxide, and dimethyl sulfide, DMS for short. The latter is produced on Earth by marine microbes and during the decomposition of organic substances. The molecule is the primary provider of atmospheric sulfur and gives off the characteristic marine scent. How the DMS signal on K2-18b is to be interpreted, however, is another matter altogether. It was not especially pronounced in the Webb data and only revealed itself when the datasets were analyzed in a very unique manner. So, until the foundation of this intriguing discovery is fully explained, a bit of patience is still required. But things do seem a little different in the case of a description that Webb took in a completely different location. Despite all the exoplanets that have already been discovered, various pictures of these alien worlds are still hard to find. Most of the time they simply appear as bright spots in infrared light. However, there is a much cooler case. A few weeks ago, Elizabeth Matthews and her team from the Max Planck Institute for Cosmology in Heidelberg succeeded for the first time in making a cold, older exoplanet directly visible. The foundation for the picture was laid by studying the triple star system Epsilon Indi, which is located only 12 light-years away. While the astronomical triplet is made up of two brown dwarfs and the orange dwarf star Epsilon Indi, earlier spectral analysis had already shown the presence of a large planetary companion. An examination with Webb's near-infrared spectrograph later confirmed that the system indeed harbors an exoplanet, but it was in a completely different location than earlier studies had suggested. The simple explanation for this is that previous studies had grossly underestimated the mass and orbit of this giant gas planet. Essentially, we are dealing with a celestial body that can confidently be described as a superJupiter. We recall that the largest member of our solar system, Jupiter, has a diameter of around 140,000 kilometers and a mass of 318 Earth masses. However, the bright spot of light that the scientists identified in the pictures of Epsilon Indi is likely several times the mass of our Jupiter. This newly discovered superJupiter orbits the primary star, Epsilon Indi, in a relatively eccentric orbit, the greatest distance of which is approximately the distance between the Sun and Neptune. As a result, this system's superJupiter takes a staggering 200 years to complete a full orbit. And it was indeed this unusual orbit that explained the incredible deviations in earlier observations. This is because the planet had actually been identified at the point in its orbit closest to the star and mistakenly assumed to be in a circular orbit. This new analysis not only led to an orbital correction but also uncovered some of the exoplanet's characteristics. For instance, the temperature here drops to around 0 degrees Celsius on average, and with an age of about 3.5 billion years, this gas giant is actually no longer a planetary youth. Or, then again, exoplanets, up to this point, all were under 500 million years of age. The majority had under 100 million years added to their repertoire. Against this background, Epsilon Indi AB is not only the coldest but also, by far, the most aged exoplanet that has been directly imaged to date. The corresponding pictures are, of course, not only beautiful to look at, but for the researchers, they also hold enormous potential for gaining new insights. For models, aged exoplanets of this kind are ideal for putting our models of planetary development to the test and for gathering new data about the later stages of extrasolar worlds. At the same time, however, Epsilon Indi AB still holds a few secrets. For instance, parts of its radiation in the shorter wavelength range are literally being absorbed. There may be clouds in the gas giant's atmosphere responsible for absorbing the infrared radiation, although chemical compounds like methane, carbon dioxide, and carbon monoxide are also potential causes. Conveniently, the scientists are already planning to explore the results, and provided nothing unexpected happens, the real reasons for the suppressed radiation transmission will soon be explained. And speaking of suppression, you are now welcome to press the button below our video to support the subscription flow. So, join our community now and never miss an exciting video from us again. We'll see you soon.